We are live now, sir. I'm going to mute myself, sir.
Yeah. Yeah, good afternoon all. Welcome to this live session of this particular course. Turbulent combustion theory and modeling. So you can post your queries in that chat box so that we can try to clarify the same. Not wrong, I guess this is already you are in the 8th week of the course, so I hope it's going well. There would be another 4 weeks of lectures which are remaining, and then follow-up exams and things like that. Now, anybody is online, please post your queries, and meanwhile, we'll try to kind of answer some of the questions which are posed by some participant. So this is regarding to Mr. Roger Tuwalia, who has some, he has posted his queries like in answer sheet of the assignment, numerical calculation is missing and reasoning behind correct answer of theory related questions are missing, hence mostly the assignment solutions are of no help, kindly address. Okay. Yeah, to first of all, thanks for this query. Just to re-emphasize that, I have gone through your queries and I'll try to clarify as much as possible, but to add on to that thing, I think most of your queries are quite trivial, I would say. If you go through the books and if you go through the lecture notes, so those, especially the questions which are not having any calculations involved, then they are straightforward, and they are the, I would say they are more fundamental questions. So that is why those questions are given in the assignment, that how much you have understood the material which has been covered. So if you understand the fundamentals of that thing, then those questions are coming out of that. So for that, that extra bit of reasoning means that we are going back to retake the class, so which I don't think is very much necessary. Okay. So I would suggest that, yes, you can have this query, but you need to go back to textbook and read through that and clarify those fundamental queries. Because now coming back to your again one after another assignment related. So let me start with or begin with your assignment 1, where you have doubt about question 6 and 7. So which involve these both questions involve some calculations. Now this is again, as I said, this is a very standard calculations which is covered in the class, where you have the calculations of stoichiometric mixtures, how to get the stoichiometric, equivalence ratio calculation. So for that, what you need to do, basically you write down the first chemical kinetics of the complete stoichiometric equations when C3H8 is burning with air. Once you have a balanced equation, then using your, again, the basic definition of equivalence ratio, which is phi equals to failure ratio stoichiometric, then you would be able to get that answer. So only thing here is that you need to take into account the year. Now same thing, it's just as an now when you write an stoichiometric equation, then typically while burning the hydrocarbon fuel, you will get CO2, but instead of CO2, you will have some CO. So once you have CO, the balance would change. And once the balance is changed, again, the same calculations would be taken into account. So that's assignment number 1. Assignment number 2, you have again 354. So if I look at it, assignment number 2, so question 3, methanol combustion PV 100%. So again, this is 345. Yeah, 345. Again, these are related to your basic definition. Most of them are related to basic definition. So once you read through the material, you should be able to get the answer here. Apart from the material which has been covered, I'm also not sure what exactly kind of answer you are looking for here. If you would have been online, that would probably clarify. Now the question number 4 here, probably the Gibbs function, then you write down the expression for the Gibbs function and try to find out for this one, in that calculations, what would be the change of Gibbs free energy or Gibbs function, so that whether it's positive or negative, then you would, accordingly, you would be able to see the correct answer. Going forward, in assignment 3, you have 1, 3, 4, 5. Again, 1 is again fundamental reasoning. 3, so that's again the same thing, which is a standard temperature and pressure reaction. And the 5, that involves some calculation, but the hint calculations are already given. So reiterating the statement, you need to really look at the note, or you need to go through the lectures, or rather the book, because this is already the answer has been given. So if you are following the expression, then it is straightforward. Already the answer which are given there is just following the these things. Now, assignment 4, you have few more. So if I see that you have 2, 3, 4, 5, 7. 2, there is nothing extra to be mentioned. Again, this is fundamental understanding of the premix flames, or the basic idea. 3 is the same thing. 4 is the same. 5, again, it's a basic difference between your premixed and non-premixed flame. So, and then 7. So all of these are the basic understanding about premix and non-premix flame. So you need to really go through the lecture materials carefully. That is why these queries are coming up. Or if you are not able to follow, then you should go back and look at the textbook. In assignment 5, you have 1, 2, 3. So 1, which is again, this has been discussed in the class. So there is an expression for the non-premix flame. So how you can calculate the length when there is a burner of certain diameter, then you can find out the length of that. So this is approximated. I think it is there in the lecture material at the beginning of the non-premix flame. So the calculation is shown. So if you plug in back the numbers, you should be able to get it. And now 1, 2, 3. 2 is again the same calculation, changing the diameter. So 2, 3, and 1, 2, and 3. Okay, that's again with respect to soot formation. Again, this is the understanding that we have discussed while talking about the diffusion flame, when soot forms and what is the logic behind the soot, and specifically you get the soot formation when you are burning hydrocarbon fuel. And then that brings out that particular questions. So again, in summary, what as I mean kind of feeling that I have, that you need to go through the material carefully, or you need to look back your fundamentals of, if you're still finding it difficulties, then you should kind of go back and look at expo. And these questions are very, very basic to those understand. Yeah, Rajat, I have already answered your question. Rajat, we have not done numericals, but the equations and everything are shown in the lectures. So you need to really get through those carefully, because the queries that you have posted, most of them are coming out of the fundamental understanding of basic definitions. Okay. Yeah, just I'll give one more shot. I'm not sure how much, Rajat, it would be really helpful, but let me give a shot. Like, for example, I'll pick up that particular question of equivalence ratio. So, for example, there, for the year, if you write the equation for the propane with air, then you have to write down the, as I said, balance equation. So balance equation means it is going to burn with the air. So 1 mole of C3H8 is going to react with the air. Air contains oxygen and both nitrogen. So this would be O2 plus 3.76 of N2 in that's how. Then you can actually try to find out how much oxygen is required or air molecule is required. So if the balance equation I have to write down, it would be C3H8, which is 1 mole, then 5 moles of air, which is O2 plus 3.76 N2, which will give you 3 CO2 and 4 H2O. Then you use your basic definitions of equivalence ratio, which is your fuel air ratio, actual fuel air ratio to fuel air ratio stoichiometry. Okay, so using that you'll be able to get this calculation. So this is probably, I would say, one of the very starting point of any combustion. So if you are still finding that difficulty, you have to read through books, or maybe before taking this course, you might need to take basic thermodynamics or basic combustion course, which are more in fundamental or richer, or basic thermodynamics course. Then probably it would be helpful. Okay.